Alright, and welcome to Factoring Quadratic Functions, Level 2. Now, in this one, 1A, what we want to do is go ahead and solve the quadratic function below. So this is the exact same as our previous problem, except for here, we actually have a special case. Alright, and if you did the Ultimate Guide to Factoring, you should know this. We call this a difference of squares. This is why I'm your math teacher and not your spelling teacher. Okay, so there's something here going on. We have f of x is equal to x squared minus 9. And 9 is a special number. What is 9? Why is 9 special? Well, 9 is something that we call a perfect square because we can take the square root of 9, and the square root of 9 is actually going to be a 3. Okay? So if I were to take the square root of something like 2, I think it's something like 1.4. I'm just going to make up numbers here, like 5, 3, 2, 1, 7, dot, dot, dot. It goes on forever. It non-repeats. So the square root of 2 is something that we call an irrational number. And the square of 9 is just a perfect number. It's 3. So what's another example of a perfect square? Well, we could take the square root of 16. That's 4. We could take the square root of 25, that's 5. We could take the square root of 49, that's 7. So understand this whole page right here, this whole level 2 problems, they're all going to revolve around things that are perfect squares. Okay, so with that being said, let's clean this up and let's solve problem 1a. Okay, so here we have f of x is equal to x squared minus 9. And of course, similarly, we set this equal to 0. And we're going to break it down very much the same way. X squared breaks down into x and x. And then we take a look at this negative 9. So remember, we discussed that 9 was a perfect square. And so if you take the square root of 9, you get 3. So in this case, we're going to break this down into positive 3 and negative 3. And that's how you do it. Whatever the square root of that last number is, if we're dealing with a difference of squares, that's going to be the numbers that go there, a positive and a negative version. Okay. From here, we can set our factors equal to 0, much like in our previous video, and x minus 3 is equal to 0. And of course, you just solve for x. Minus 3, x is equal to negative 3, and plus 3, x is equal to positive 3. So let's go over here in orange and go to the left, 1, 2, 3, put our point. To the right, 1, 2, 3, put our point. And our a value is a positive a value. So this U-shaped function will open up. And that's all we need to know for today. Okay, let's go on to a second and third example from the assignment just so you get plenty of practice. Okay, so I noticed that 5a is f of x equals x squared minus 100. And I noticed that there's no x term in the middle, so it's just x squared minus this 100, which is a perfect square. And I want to ask y'all, what is the square root of 100? Well, hopefully you know that. It is 10. A square root is asking the question, what times what is equal to 100? But both of those numbers actually have to be the same number. So you would say like, oh yeah, 10 times 10 gets you to 100. So the square root of 100 is 10. Which means we set f of x equals 0. Now I have x plus 10 and x minus 10. Okay. And let's do our thing. We'll set the expression here, x plus 10 equal to 0, and x minus 10 equal to 0. And in both cases, we solve for x. So minus 10, and x equals negative 10, and plus 10, and plus 10, and x equals 10. If I graph this, what's that going to look like? Well, I'll just come over here, and I'll just call this positive 10, and I'll come over here and call that negative 10, and my function is just going to go through both of those. Our a value is positive, so it opens up. Easy, easy, easy. Okay, let's go ahead and do one more example just so you can get the practice. Okay, if you've made it to 7a, I kind of want to go a little bit more conceptual in this one, just so I can show you what's really happening here. Why do we have this kind of shortcut where we can take the square root of the number? Well, think about this. I could actually write this function out as f of x equals x squared plus 0x minus 64. Notice that my x term my x term, has been missing in all of these problems. So if the x term is missing, what that tells me is that I'm really breaking down this negative 64 into two numbers that add up to be 0. So you can think of negative 64 like, what are some possibilities? It could be negative 2 times positive 32. But if I combine those together, I would get 30. Well, that's not 0. That's why we get to take the square root of this, because the square root of 64 breaks down into 8 and 8. But it's two numbers that multiply to be negative 64, so one is positive, one is negative. And when you think about that, what is 8 minus 8? Well, it's 0. So that's why we get to take the square root of this, because these two numbers essentially cancel out and make that middle term equal to 0. Okay, so let's just do our trick though. We set f of x equal to 0, and we factor it. We know that x times x gives me x squared, and then the square root of 64 is equal to 8. So we write plus 8 and minus 8. And from here, we can just go ahead and solve it like normal. X plus 8 equals 0, x minus 8 equals 0, minus 8, minus 8. And I'll just kind of drop this down past here. We get x equals negative 8, comma, plus 8, x equals 8. And we could even write our solution like this. X equals a number, comma, a number, telling us that this is going to cross here at negative 8 and positive 8. And just like our previous however many problems, we have a positive a value. So once I find my two solutions, I know this quadratic function opens up. Alright, I hope this video is very helpful for you, and I'll see you in our level 3 video.